warahmatullahi wabarakatuh. Salam.
Waalaikumsalam.
Om Swastiastu, Namo Buddhaya, salam kebajikan, selamat siang, sejahtera bagi kita semua. Hari ini kita memasuki lecture ketiga dari 4 lecture serial Ambassadorial Lecture ke-11 tahun 2023. Selamat bergabung dalam lecture ini, Ibu Dr. Diah Madubranti, selaku Kepala Pusat Studi Jepang, Universitas Indonesia. Ibu Kawakubo Yuriko, selaku Atase Pendidikan Kedutaan Besar Jepang di Indonesia. Welcome to the 11th Ambassadorial Lecture, year 2003, the third lecture from 4 lecture series. Our honorary speaker for today, Professor Onoda Hiroshi, Dean of Graduate School of Environment and Engineering, Waseda University, Tokyo. Selamat datang dalam webinar ini, seluruh rekan-rekan pengajar dari berbagai universitas di Indonesia dan juga dari berbagai latar belakang ilmu studi Jepang, ilmu lingkungan, ilmu manajemen, dan sebagainya. Juga seluruh mahasiswa dari berbagai universitas di Indonesia dengan berbagai latar belakang ilmu. Juga selamat datang bagi seluruh praktisi dan peminat bidang lingkungan, khususnya manajemen persampahan. First, we would like to invite for opening speech Dr. Diah Madubranti as Head of Center for Japanese Studies, Universitas Indonesia. Ibu Diah, the time is yours.
Thank you, Ibu Susi. Good afternoon for all the participants. Good afternoon, Professor Onoda. But let me do my speech in Bahasa. Yoroshiku onegai itashimasu. Hai. Selamat siang. Selamat datang para peserta kuliah umum seri ketiga tahun ke-11 di Ambassadorial Lectures. Salam sehat dan salam sejahtera bagi kita semua. Yang saya hormati Profesor Onoda Hiroshi, Dekan Sekolah Pascasarjana Teknik Lingkungan dan Energi, Yang Mulia Ibu Kawakubo Yuriko, Atase Pendidikan Kedutaan Besar Jepang untuk Indonesia, Ibu Julian, Staf Kedutaan Besar Jepang untuk Indonesia, yang saya kasihi Ibu Ketua Pelaksana di Ambassador Lecture Series ke-11, Ibu Dr. Lea Santiat, yang dibantu oleh panitia kegiatan ini, oleh Ibu Susi Nataliwati MSI, Ibu Nisa Natalia SIP, Bapak Julius M. Hum, dan Ibu Gabrielia Astrid, serta seluruh tim penyelenggara dari Kedutaan Besar Jepang untuk Indonesia dan dari PSCUI. Tema kuliah umum dari rangkaian di Ambassadorial Lecture Series ini sudah diselenggarakan selama 11 tahun dan selalu menyajikan tema-tema menarik yang terbarukan. Kalau minggu lalu kita menyajikan tema pendidikan sekolah Jepang, Jakarta pasca pandemi, kali ini Profesor Onoda memaparkan topik yang sedang digalakan juga di Indonesia, dengan tema topik Smart City yang terfokus pada infrastruktur sosial. Infrastruktur yang tidak pernah bisa lepas dari kehidupan masyarakatnya. Dalam upaya membangun kembali negeri akibat pandemi COVID-19, pendekatan infrastruktur sosial adalah landasannya. Misalnya, bagaimana pentingnya pengolahan limbah di setiap negara. Kali ini paparan mengenai bagaimana lahan limbah di Jepang pasca akademi, kita perlu belajar banyak dari Jepang mengenai pengolahan limbahnya. Bagi orang-orang yang pernah pergi ke Jepang, kesan pertama ketika sampai di Jepang, mereka pada umumnya akan mengatakan, Jepang bersih. Ketika saya dari penginapan berjalan kaki menuju stasiun di daerah Shinjuku, Tokyo pada tahun 2019, di muka saya ada seorang wanita lansia yang lebih tua dari saya, memungut sampah yang ada di tengah jalan. Saya bertanya, apakah yang saya perlu bantu? Wanita itu berkata, tidak. Saya hanya mengambil sampah yang ada di muka saya. Kesadaran yang sangat tinggi ini dari masyarakat Jepang akan kebersihan sudah tertanam sejak lama. Karena itu, tahukah para hadirin bahwa di Jepang sekarang ada wilayah yang sudah zero waste. Baiklah, untuk tidak memperpanjang waktu, mari kita bersama-sama mendengarkan paparan Profesor ONODA Hiroshi yang saya yakin akan menjadi pembelajaran yang terbaik bagi kita semua. Pada kesempatan ini saya ingin mengucapkan terima kasih kepada Profesor ONODA Hiroshi yang di tengah kesibukannya, di tengah waktu yang sangat sempit, beliau masih berkenan dan menyampaikan dan menyempatkan diri memberikan kuliah umum yang amat bermanfaat bagi kita semua. Terima kasih juga saya ingin sampaikan kepada Ibu Kawakubo Yuriko yang dari awal kedatangan beliau ke Indonesia itu sudah disibukkan dengan di Ambassadorial Lecture Series. Terima kasih juga yang saya sampaikan kepada Ibu Lea Santiar, Ibu Susi, Ibu Nisa, Natalia, Pak Julius, Ibu Astrid, dan tim penyelenggara atas kegiatan ini karena upaya dan kerja kerasnya yang bukan main. Terima kasih. Mudah-mudahan kali ini pun peserta seminar dapat mengikuti dan dapat menjadikan pembelajaran yang terbaik bagi peserta. Selamat berseminar. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih Ibu Dia. We would like also to invite Ibu Kawakubo Yuriko as Education Attaché of Embassy of Japan in Indonesia. Kawakubo-san, the time is yours.
Terima kasih. Professor ONODA Hiroshi, Dean of Graduate School of Environment and Energy Engineering, Waseda University. Ibu Dia Madhuburanguti, Pusat Studi Japan, Universitas Indonesia. All the distinguished participants, ladies and gentlemen. Selamat siang. Nama saya Kawakubo Yuriko, Attaché Pendidikan dari Kedutaan Besar Japan. Terima kasih banyak atas kesempatan hari ini. Thank you very much for joining us today for the Ambassadorial Lectures. In particular, we are grateful to Professor ONODA for taking time out of his busy schedule to give us a valuable lecture. On behalf of the Embassy of Japan in Indonesia, I'd like to take this opportunity to say a few words. Japan Research Center of Universitas Indonesia and the Embassy of Japan have been co-organizing a series of Japan-related lectures every year since 2012 for Indonesian university students. Today, Professor ONODA will deliver a lecture from the field of environment. He is engaged in research and development of new technologies and social systems for the advancement of a recycling-oriented and low-carbon society, and established an environmental university venture. I'm looking forward to hearing his lecture on smart approaches to waste management with you all from now. After his lecture, we will have a Q&A session. So I hope that many participants will ask him questions and share your comments. And I believe that will give us many ideas. Finally, I'd like to express my sincere gratitude to the staff of the Universitas Indonesia for their efforts in organizing today's lecture. I'd like to conclude my remarks by wishing that we learn a lot from each other. Terima kasih.
Terima kasih Kawakubo-san. Now, it's time to enter the main session. I would like to introduce our moderator for today, Dr. Lea Santiar. She is a lecturer in Faculty of Humanities, Universitas Indonesia. Her specialty is Japanese language and Japanese linguistics. Lea Sensei, the time is yours. Masih mute, Bu Lea.
Thank you very much for the time. Here as the moderator for Professor Onoda. First of all, I would like to read Onoda Sensei profile. So I have here in 2006, he graduated from Waseda University School of Science and Engineering Department of Mechanical Engineering and pursue a doctoral degree in engineering. Now he is as the Dean of Graduate School of Environment and Energy Engineering, Waseda University. His specialization is environmental engineering, energy engineering, environmental impact assessment, and environmental policy. So we will like to invite Onoda Sensei to present his lecture for today. The time is yours.
Thank you for your introduction. So I will start my presentation. Okay, good evening, everyone. My name is Hiroshi Onoda from Waseda University. So today's title is Smart Approaches to Waste Management, focused in waste management in Japan. So my background is mechanical engineering, and my area is covered waste management and also energy system. Like here, smart community or smart cities or smart town projects with renewable energy utilization system or biogas food waste, or in Japanese we say zero energy house, we call ZECH, and or with the biomass, because Japan has a lot of potential of the woody biomass energy, and also this kind of next generation mobility system or personal mobility or self-driving system, and also the recycling system, or the ELV mean the end-of-life vehicle, or we is a electronics product. Okay. So and my mission of our laboratory is to design the next generation of the social system. So first of all, I will talk about the background. So for example, about the smart city, usually the megatrends like the population growth or all of us is mentioned as a background. So it is as in 2050, the 70% people lives in the city. So we have to be smart, usually said. But in Japan, the population is already peaked out, okay, and sharply in decreasing in Japan. This is only country in the world in this kind of phase. So when the population will decrease, the public infrastructure, including waste management, it's very difficult to maintain or be sustainable. Okay? This is a different situation of all of the world in Japan. So, and when we discuss about the smart approaches, we have to focus not only the single issue. We have to focus on the several infrastructures. I always say, for example, the ICT, the information technology, we can get the information all over the world at hand. So it is said that it's easy to transfer this kind of infrastructure. So one of the energy, electricity power, that we can transfer easily to the in the distance throughout the grid. It is a characteristics of the electricity power. But the thermal energy, this is also in the one of the energy. This is very difficult to carry out far away. So if we want to use efficient use, we need to use a very close area, this kind of thermal energy. Also, when we discuss about the smart cities, usually the local production and the local consumption is one of the key words. But if we think about the local production and local consumption, we think from the right side, from this kind of infrastructure. So today's theme, the waste management, is including then this kind in this figure as a recyclable resources. So it varies with the quality or quantity or cooperation with surrounding infrastructure. So it is difficult. Some scale is best available for us. So the waste management facilities are often referred to as NIMBY facilities. So not in my backyard. Everyone knows that this infrastructure is very important for us, our city lives, but not in my backyard. So however, I think that they are important, but must be reconsidered of this kind of waste treatment facilities, because the waste treatment facilities is fundamental to the citizen lives, and also that cannot be replaced, not even temporarily. And also in Japan said it must be the basis for the local development, this kind of waste incineration plant or sewage treatment plant. And today's lecture, I will focus on this kind of incineration plants. So this background has laid the appearance of advanced waste treatment facilities in Japan. I think in ASEAN countries, that infrastructure development related to waste treatment and sewage plant will become more active. Now, in these areas, I think there is know-how that Japan can provide to the ASEAN countries. So this is a few examples. This is a Musashino in the Tokyo area. This is a waste power and natural gas coordination plant, and it's next to the city hall. This is a very famous incineration plant, and produce electricity for the city hall when we get a disaster. Okay, and this is a biogas generation plant in the Toyohashi city. They're close to Nagoya. In the biogas generation plant in the sewage treatment. Because of this, we can very low cost operation by the linkage with the sewage plant, with a wastewater treatment. So the question is that overall, however, are the Japan's waste management facilities is efficient? This is today's question. So in this section, I will focus on the waste incineration plants, and my answer for this question is no. I don't think it's efficient, Japanese one. So they cannot be efficient. So I will tell the reason why. So this is one indicator called the R1 index in Europe. This is a well-known indicator for the energy utilization rates of the waste incineration plants. So for example, this is a ratio of input energy and output energy. And for example, the rate 0.60 means about 60% energy is utilized from the waste energy means. So in Europe, they say if the index is over 0.6, this is a recovery facilities. But less than 0.6 is a disposal system. This is used as a guide of the public finance or public funding when they replace or complete new facilities. So that this figure below showed the R1 index applied to the Japanese incineration plant. As you can say, almost the facilities is less than 0.6. Okay, the Japanese incineration plants cannot meet the regulation or index of the European incineration plants. So this is the reason why I cannot say a Japanese plant is energy utilization is efficient. So what are the problems of the Japanese waste incineration facilities? So the reason that I mentioned here, the most there are more than thousands of waste incineration plants in Japan, thousands in Japan. And however, more than 50% of them, they are the less than 100 TPD, ton per day. So it's the very small scale plants are located in Japan. So the small incineration plant, we cannot use energy well because of the restricted of the technology. So here is a percentage of the waste energy use is then the 50 ton per day, less than 50 ton per day, and that means the 50 and 100 ton per day. And we cannot use energy in the small scale plants. So as I said, the incineration plants are the NIMBY, not in my backyard facilities. So they are also located in the remote area. So we cannot use the energy or heat energy well in the Japan. This is a reason why the energy utilization rate is very low in Japan. So the Ministry of the Environment, I call MOE, is a government of Japan that promotes the waste management policies. So they recommend 6 methods for the wide area expansion. We call in Japanese koikika, wide area expansion, and the centralization. In Japanese, shuyakuka. Okay, stop the small scale incineration plant and create the largest one. They promote Japanese government. So they show the 6 methods for the local government. So the setting up cooperative society in Japanese, we call kumiai. So the cooperation with neighborhoods. So several local governments cooperated for the create the incineration plant. And the waste disposal sharing by type means, for example, in the A city is set the incineration plants, and the B town has a biogasification for the waste, means the second one. The acceptance in the large city is means, for example, sets a large scale incineration plant in Jakarta for the around surroundings, small village or town. This means the third one. And the multiple support is become important in the, for example, when the disaster, many waste occurs, and so the cooperate to each other. I mean the mutual support. And the blue letters one is a new message from the MOE cooperation with other infrastructure like the sewage treatment plant or collaboration with the private sector. So that Japanese government try to promote to the expansion and centralization like this kind of message. So also in August 2021, 1.5 years ago, the Japanese government also show the medium and long-term scenarios for the carbon neutrality in 2050 in the waste and the resource recycling sector. So I'm sorry, the basic paper is only in Japanese, so they say they have to achieve the carbon neutrality in waste and the resource recycling sector into 2050. Okay, it's very difficult for us, and I also joined to this discussion, but it's very difficult, and we tried. How do we do that? Okay, so in this this kind of scenarios, the direction of the main technical element is shown in the 4 technologies is shown. The first one is a biogasification by methane fermentation with a biogas system for the food waste. This is why, because in Japanese government also try to separate the plastic resources to the material recycle or chemical recycle. So the burnable garbage will be the biomass almost. So the incineration plant will not be the only technology for us. So the methane biogas system will be the one option. And the B is a large-scale heat utilization system. So about this, I will show later in this lecture. And the C means the chemical recycling, the high-quality recycling of the plastic with the oil refinery or something, or chemical producers. And D means CCUS. I think someone knows all these keywords is carbon dioxide capture, utilization, and the storage system. And usually, this CCUS discussed about the coal fire plant or the large-scale coal fire plant. But in Japan, also in the waste incineration plant, we have to introduce this kind of technology. So the utilization means use CO2 and with hydrogen and produce methane or methanol and create a new material from the CO2. This is a CO2 technology. But to realize this kind of technology is very difficult because of very high cost also technology. And this is my own opinion for these scenarios. Not by MOE, my opinion. This is so the common issues are the location or infrastructure linkage. So it's important where we can establish the incineration plant. For example, the methane fermentation biogas system, it will be more effective on the site of, we can set on the sewage plants because we can use the infrastructure of wastewater treatment facilities of the sewage plant. It's maybe the low-cost operation. We can realize a low-cost operation. And also, large-scale heat regeneration or CCUS is to be carried out near the chemical plant or oil refinery plant. Okay, so if the strategies are built from the same perspective of before this kind of planning, the effectiveness of such a facility will be limited. I think so. So very difficult because in Japan it's very difficult to keep the location for the incineration plant. So the local government has confused this kind of message. So I will show the large-scale heat utilization. I will show the European example, not Japan, sorry. So this is an incineration plant in Hamburg, in Germany. And this red line is a steam line and supply the steam directly to the oil refinery plant. Okay, I think you can understand. So this is a very large scale incineration plant. So the 800,000 tons from the Hamburg themselves, and 300,000 tons from the surround area. So they collect the waste from the wide area, and from the 60 kilometers residue zone, they collect the waste. So in Japan, this is impossible, this kind of scale, to create this kind of large-scale incineration plant. So this is the energy balance, and the input is 94% is energy from waste, and used 47% in the oil refinery plant. Okay, and usually it is said in the Europe there are the district heating demand, so they can use heat utilization, but this is only 4%. And electricity, so the Japanese incineration plants are only focused on the electricity generation, and but in this case it's only 8% for the electricity. So we know this type of energy utilization is the best available method. Okay, but we in Japan we know this kind of case studies, but we discussed, and in Japan it's impossible to realize this kind of process in that this is come large scale and cooperate with the industry sector was very difficult in the Japanese waste management situation. But recently the industry also is changing their mindset. It's caused by the carbon neutral, so that we are continue the feasibility study in the Chiba prefecture. They have the large-scale industrial park in the chemical industry or something. So that we discussed the setting the large-scale energy center like Hamburg, and we need the sorting center, and the high-quality plastic maybe into the material or chemical recycle, and create a raw material for the industry, and other plastics to the energy recovery. The direct use of the steam is a very, most efficient process, I think. I will try to create one model in Japan. So the next step, I will talk about the direction of waste management and the recycling system with a viewpoint of the post-corona. I will, with the corona, we explained the corona or COVID-19, the concept of contactless waste management has become increasingly important in Japan. Here, I will show you some of recent results of our research group, introducing the new technology. So I don't know, as you know, this photo of the island. This is Teshima in Seto Naikai, you know, near the Shikoku Island in the west part of the Japan. And this is famous as an illegal dumping site. The large-scale illegal dumping. The black one is illegal dumping waste, and from the area we watched from the drone. Okay? So we watched this kind of problem and try to introduce new technology like drone and survey the amounts of the illegal dumping of waste. And we tried to introduce advanced technology in the waste management or recycling system. So the recent discussion is, I want to share with you the small lithium-ion battery. You know, I think it's included in your smartphones or mobile batteries. Everywhere the lithium-ion battery is used. So this is one big issue in Japan, because the fire occurs caused by the lithium battery is very, very increasing and destroy the recycling line. This kind of, they are big problem because we cannot separate and confuse to the other burning garbage, and yeah, it's burnable. So we developed the catch the fire by the AI system, and move the fire hydrant system, the automatically system. Okay, so that this is a picture that catch the fire from the AI, and that we try to demonstrate to the some incineration plant, also the recycling facilities. So the lithium batteries should normally be pre-selected, but we are getting inquiries about this kind of technology. This is become a big problem in Japan. So I want to know how about in the Indonesia? So another trial is a contactless collection system. The contactless is a contactless for the operator of the who collect the garbage. In Japan, is also they collect by hand. So we discuss about the risk of the operators. So we have a linkage with the government, and so the problem of the collection is we have many problems because the elderly people cannot separate the plastic or other resources. So we try to introduce this kind of new technology in this waste collection part. So I will show the movie. So that this mobility, this is we propose the concept of the moving dustbin. So that this blue t-shirts man. So the mobility has a camera and catch people and follow automatically. So that we can use with this kind of Segway mobility, so that we can carry out the big luggage about 200 kilograms or so. So that we try to use this technology in the event. Okay, so that usually, if you this kind of event we do, the government sets the garbage bin, but in this event we only set this kind of mobility, and waste collection could be carried out with the need to install waste bins at the event site. The we can so like this. So yes, and also in the other events, so that this kind of small mobility we can charge by the PV only, and we propose a multi-benefit concept, so that not only waste collection. So that before the opening of the event, support the transport the materials of the event, and in the lunchtime we use as a moving bins, and because many people have a lunch and waste some containers of the plastics, and also support the store operators, so that to bring some drink or something, sales goods. And after the event, we support the cleaning the garbage to collect in this sense. So this kind of event, there is no regulation or comparing with the public road, so that we try to use in these opportunities. So after collecting, we have to move. This is a container used in Japan, about 700 liter and about 200 kilograms. So we try to move from the mobility, and so that, and after moving by the mobility, connect to the collection vehicle, okay, waste collection vehicle. and connect and dumping. Usually, we have to the collectors may be touched in the waste, but we can realize the contactless input. But the difficulties of this kind of technology is so that we have to know the regulation of the Japanese rules. There are many rules. So this process is the one of the we can reach as in Japan. So so our image is like this: the setting to the container and collecting at the night or early in the morning, and so the collection vehicle come and reverse feeding into the collection plant. And the movie under there is a new model and introduced by the self-driving system. Okay, you know, LiDAR for the using technology introducing the self-driving system. This is a demonstration test in the our university campus. Okay. So I will try to implement this kind of technology in the smart city because the new technology has to clear many regulations. So we try to demonstrate and implement in the small area because this is a community that this is a railway station and of the Tobu Tetsudo, one of the famous railway company in Japan. And this is a like small size shopping mall. You know, Ion. Ion. I think it's famous only in Indonesia. And this is the Toyota Home, the residence company of the Toyota Group. They said about 170 households here, new town here. And this small-scale new town, I will try to introduce this kind of personal mobility or contactless waste collection system. And we propose with rule making, not only technology, that we have to change or propose a new political way to introduce this kind of new technology. So this is our approach, not only technical approach with social implementation. So the next project is a project with Tokyo Metropolitan. She is a Koike Tochiji, one of the famous governor in Japan. And so the target is achieve the automated waste treatment and recycling development of sorting robots system. Okay? The sorting process is usually occurred by hand in Japan also. So that we try to create the robot which can sorting the plastic or PET bottle or something. So because this is a backyard of the famous building in Japan, so that usually we separate in the bin, but after collect the operators, so separate the plastic or something by hand. Everywhere. For example, large shopping mall, or we researched some buildings, so that everywhere they separate by hand. So the building manager wants to stop this kind of work. So that if we realize the robots, they cannot do this kind of work. Okay. So that this is after the plastics from the buildings and come to this kind of process company, and you can say the 5 or only you can 2 operators, but here the 5 or 10 workers sorting beverage container, and the beverage container to the into the line, and but 70 or 80% plastic is like this. So as you know, these kind of plastics we cannot recycle, material recycle or chemical recycle. Very difficult because it's very dirty. So this kind of plastic is discharged from the small and medium-sized restaurants. So this kind of manager say to separate more well, but they cannot separate. So they're very dirty, and this kind of plastic has to be incinerated. Okay, so very different. This is a current situation of Tokyo. Okay, so the recycling of the plastic required a very high quality plastic material recycle or chemical recycle. It's very difficult to separate from this kind of plastics. So that we try to develop the PET bottle sorting robot, and so the PET bottle it's easy to grasp from the AI because the shape is common. Okay, so we want to set this kind of robot in the backyard of the building. So we try to improve the compactness for installation in backyard. This is in ongoing trial. So this is another type of robot targeting the waste from the construction or building after disassemble the building, many large scale. So usually this is a belt conveyor, and the human sorting. This is the concrete block or wood or plastic or concrete, and we set like this the conveyor and the robot, and catch the AI and separate and moving the roboting gun. So today, I will share you the difficulties of this kind of technology. So this is a robot that the target is a concrete block, and they catch and separate like this. This is a good way, but like you can show this. The ability of the robot arm and the gripper is restrictive. They cannot work to the weight concrete block. So if this kind of large scale block come, the robot will be damaged, and so we have to install that's avoid the substances into the robot. So the productivity that doesn't improve that kind of process. So we propose that the ability of the robot is limited. So the combination with the human ability and the robot ability is important. We say the coexist system is important in this area. So the technological problem is we have a lot of problems here. So the core technology of the robot is the camera. So the AI for the image detection is very becoming improvement in the worldwide technology development, and the pickup robotic arm technology that we have in Japan. Also, we have many experience in the manufacturing company, but in the waste or recycling area, we have not enough experience. So we try to develop this kind of development, and so it's maybe the useful technology for this area. So the title of this slide is a mistake. I'm sorry. That this is an example of the another discussion by the plant engineering manufacturers. So they try to develop the remote control and AI operation service in Japan. I think it's very high level project in the Japanese plant engineering company. So we can realize from this kind of technology, operate the incineration plant in Indonesia from Japan. We can use this kind of technology. Okay, this is a last slide. Okay, so this is a figure in the remote island in Japan. So this is a drifting rubbish like arrives in the come every day here, but it's not from abroad. It's from Japan because of the location. So in this island there are a very small incineration plant, but this plant has stopped because toxic substances occur, and the government has to stop. So the waste from the island and is carried off the island and by the ship, and the waste costs increasing very high. So what occurs in island? This is a picture of the result. The illegal dumping by the island residents occurs in Japan because they have to spend a lot of money for the wasting. So I want to say that in some area, the Japanese waste management is failing now. It's not sustainable. So we have many problems, and so we have to introduce the smart technologies I showed today. So that's my presentation. Thank you for your attention.
Thank you very much for Onoda Sensei that we have already listened to his presentation. Maybe we could give a reaction on our Zoom. Thank you very much.
So, may I introduce Dr. Andante?
Yes, of course.
Please, so she helped the discussion, I think. Yeah.
Okay.
アンナさん、一言、ちょっと自己紹介だけ。
はい、わかりました。インドネシア語ですか？
どっちでもいいですよ。
Indonesia go, okay.
Indonesia go, okay. Oke, selamat siang Bapak-bapak, Ibu-ibu, teman-teman sekalian. Nama saya Andanta Hadipandia Suargo. Saya pada tahun 2010 saya adalah mahasiswa pertama Onoda Sensei untuk mahasiswa doktor. Lalu 2013 saya lulus dari laboratori Onoda Sensei, kemudian bekerja di Tokyo Institute of Technology selama 4 tahun. Kemudian saya dipanggil kembali oleh Onoda Sensei untuk bekerja di Waseda University sebagai asisten profesor Onoda Sensei, dan saya bekerja sampai sekarang di Waseda University sebagai peneliti. Saya juga pada saat ini membimbing beberapa mahasiswa S3 Onoda Sensei. Ya, berdasarkan petunjuk Sensei, saya bisa membantu mungkin untuk sesi tanya jawab, tapi kalau ada yang saya kurang mengerti, mungkin Onoda Sensei juga akan menjawab. Terima kasih.
Terima kasih banyak Ibu Ana. Senang sekali ya ada dari orang Indonesia ada di Waseda University. We are very proud to have Ibu Ana today, an Indonesian citizen in Waseda University. Mudah-mudahan banyak adik-adik nanti akan mengikuti jejaknya Ibu Ana ya. Okay, so I would like to enter the Q&A session. I think if you have a question, you can write it down in the chat box or you can raise your hand. Silakan kalau ada pertanyaan bisa mengacungkan tangan, raise hand, atau bisa juga menuliskan dalam chat. Mungkin saya persilahkan 3 orang penanya dulu. Wah, kelihatannya sudah ada yang bertanya di sini. 1 orang dari Bapak Erwin Kasim. Onoda Sensei, we have a question here in the chat. You may read in the chat maybe. It's in English. Mungkin Ibu Ana juga bisa membantu untuk menyampaikan kembali kepada Onoda Sensei kalau tidak jelas.
Finance no mondai desuね。誰が払うかですよね。テクノロジー的には問題ないみたいですけど、お金と
We do not see waste can be managed.
誰が払う
Apabila bisa sudah dipahami pertanyaannya, mungkin bisa langsung Onoda Sensei, kono hitotsume no shitsumon dozo, okotae ni nararetara.
はい。この、あれかなアーウィン・カシムさ
はい。
んのが、is that right? The first question.
Yes, the first question, please. お願いします。
Yes, that's right. We have also the same problem in Japan. So but as one example we have no clear answer about this question. We have to also discuss in Japan. So but in Japan, the feed-in tariff is introduced in the 2012, and the electricity from the waste incineration plant or biogas plant is one of the target of the feed-in tariff. So some recycler or private sector invest to the biogas plants, and some plants starts going on. So it's I think one of the things, but I don't think it's enough as a supporting system. So in Japan, as the waste management, so the Japanese government supports the local government. So we discuss what is the target of the public funding usually. So it's also depends on the role of the local government and the MOE in Japan, Ministry of Environment, how to support and promote this kind of project. Yes, just a comment. Yes.
Okay, thank you very much. I see there is maybe Bapak or Ibu Indra Purwadi, tapi pakai bahasa Indonesia. Apakah pemilahan awal kurang sempurna? Maksudnya menanggapi yang tadi, pemilahan itu apa ya, Ibu Ana ya? Pemilahan
waste separation. The waste separation is not perfect
in Indonesia.
Oh, it's about Indonesia. Or I'm not sure if Bapak Indra is talking about the Indonesian situation or the Japanese situation.
In Japan, I think the what you call this beginning segregation, waste segregation at home, I think it's the best in the world. But why do you still need segregation instead? Okay.
Oh, I see. Okay, so the question is, why do we need AI to help in the waste separation after collection, even though it's well known in the world that Japan is doing separation very well compared to other countries?
Yes, but it's not perfect. Okay, first one. So there is a contamination. And I showed in, so that I introduced today's presentation is mixing by the several waste. So there are many cases that's kind of, so the Japanese separation is not perfect and become problems because the people become elderly and they cannot separate. So this is a big problem in Japan. But for example, the PET bottle maybe is separated very well, and we created a good recycler. But any plastic or something is not so good. So I think we have to introduce some technology, not only AI. There's using some other sensor technology. I will try to separate. So so for keeping the high quality recycle, we need the more quality, more high efficient quality separation.
Okay. Excuse me, can I ask for another question? So that's mean separation between organic and inorganic is already good enough, but the one that you are talking about is about the inorganic separation. Is that right?
Yes. So in Japan, the organic waste from the household usually go to the burnable garbage. Okay, so the very few cities separate only some cities separate food waste, but most of all. For example, the Tokyo area is a food waste going to the burnable waste. So it's one of the big problem. How to separate the food waste or the plastic is a big issue in Japan.
Okay,
thank you very much.
Okay, thank you very much. Di bawah setelah Bapak Indra Purwadi, saya lihat ada sebentar. Tadi sudah ya, how do you separate material by infrared or based on the chemical content? Tadi masih dengan Bapak Indra ini. How do you separate material by infrared or based on the chemical content? Itu tadi sudah terjawab belum ya?
Sudah lumayan ya sepertinya. So the separation is using sensor, so it's optical sensor, and then using the robotic hand. That is the pilot project so far.
Okay.
Not by the chemical content yet.
Okay, so we have another question from Bapak Sunarto. It seems that most waste processing is used for energy. Is there any waste processing in Japan that is used as construction material, such as concrete, for example?
That's most waste is used.
I think it depends on the type of waste. Because most are incinerated, so the byproduct of an incineration plant is usually heat, and then it can be used to run a gas turbine, for example, and then it can be used to generate electricity. And also the heat sometimes is used to heat a swimming pool or something. So usually that's the area of energy recovery. But this question is good because it thinks about the higher priority of recovery, which is material recovery, which is what we should do before an energy recovery. However, depending on the type of waste that is processed, then there are certain types that can be used for like this example, concrete materials, but there are some like the dust maybe can be used, but the heat is for energy. So yes, there are two byproducts of the reaction: the materials as well as the heat and energy.
Okay, thank you very much.
Yeah, I don't introduce it today. So the Japanese has several recycling law. For example, the ELV, end of life vehicle, because ELV, the main content is iron or the steel or something, and also the household appliance, home appliance recycling, and also the construction material. We have a law. So as Dr. Andata said, it's depend on what kind of material include in some products or construction. So we have the recycling route of for each material. The residue is decreasing from the 2000 in these 20 years. So I didn't mention about in today's lecture. Yeah, I'm sorry. So,
Okay,
the plastic or or burnable garbage from the household. We almost insulation and get the energy, so the electricity or heating. That's it. I mentioned in today's lecture.
Oke, jadi yang tadi konkret itu maksudnya untuk bangunan gitu ya maksudnya ya. Tadi apakah dipakai untuk bangunan, tapi masih ada juga ya?
Ada, tergantung inputnya.
Atau juga untuk bahan baku yang lain. Ini ada pertanyaan mengenai keuangannya. Ini tadi sudah terjawab belum ya? Berapa yang dibayarkan tipping fee, average paid by government or by municipal to incineration plant? Wah, ini datanya ada atau tidak ya?
Yeah, I think this is searchable. Ikura desu ka tipping fee?
ティッピングフィーはそれもit's different of each local government. Okay, and for example, I'm in Shinjuku in Tokyo. In Shinjuku is free for the burnable, burnable plant. But large scale waste, we have to pay about, for example, the 2,000 yen. So now is 130 yen for the door. So and I think but the cost we spend in the waste management, you usually say 30,000 yen. 30,000 yen は、about そうですね、about そうで$300 per トンですね。トン。うん。から、だから、30,000 yen ton from, for example, when the expensive case is 50,000 ton, 50,000 yen per ton. Yeah, this is our order of the cost we spend on the waste management usually.
Jadi tadi kalau boleh diulang, untuk yang sampah rumah tangga itu tidak bayar ya, Bu Ana ya?
Iya, kalau di Shinjuku.
Iya, di daerah Shinjuku. Tapi tempat lain ada yang bayar ya? Oke, baik. Kemudian ini dari Ibu Liz Musonati. Saya ingin bertanya, mengapa sampai hari ini tidak ditemukan cara untuk sedemikian rupa menjadikan sampah plastik bisa terurai di dalam tanah? Bukankah mungkin ya teknologi dan para peneliti ada banyak di dunia ini? Wah, gimana nih pertanyaannya?
the question is why until today there is no technology to make waste becoming degradable in the soil. There must be something that has been made by the researchers in the world. Well, I think the answer to this is we do have biodegradable plastics already. However, there are also challenges in this area because some are partially degradable, some are fully degradable, and then in the recycling process, it becomes also confusing which plastic is biodegradable and whether it should be composted or whether it should be recycled. And if recycled, different types of plastic has different ways of recycling. And some recycling technology are not tolerant to contaminant. For example, the only PET bottle, only pure PET bottle can be recycled into virgin-like material, but like chemical recycling is very sensitive, but it makes very good products. But if the technology that is more tolerant, like thermal recycling or like mechanical recycling, they do not make very high quality products. So the reusability of the plastics itself becomes very limited. For example, if we recycle a mixed plastic with mechanical way, then the quality will be low and it will be too low to be reused in for food packaging, for example. So there's so many types of plastics and there's so many ways to deal with them. That is why it becomes complicated. But there are biodegradable plastic already. Like in Indonesia, I think we have cassava-based plastic and so on, right? And in a smaller scale, we can use that in composting materials and so on. But in a larger scale, like a metropolitan, like Tokyo, like Jakarta, it becomes very complicated because everything is then mixed together.
Okay. Thank you very much. Yes, we are facing it every day in at home or anywhere, especially in Jakarta or in Indonesia. Okay, thank you. So we have another question from Pak Jamal. Bagaimana cara mengatasi sampah cair seperti pampers dan sampah cair lainnya?
So this question is about liquid waste.
Disposal, yes.
Yeah, or liquid waste, not wastewater, precisely. Like the one contains in diapers, akacang no mutsu toka, and then other waste that contains liquid. How to deal with this? どうやって処理して。
紙おむつの話かな、これ。
そうです。はい。
Yeah, in Japan, trying to create the recycling system of the pampas でいいのかな、紙おむつ。Yeah, try to create. But now, usually go to the incineration plants.
Even though it's wet, it's okay to the incinerator.
Yeah, incineration plant. Now.
Oke, baik. Mungkin sampah cair lainnya itu tadi agak sulit ya, karena kan cair itu cair ada oli, ada minyak, itu mungkin.
Betul. Sebetulnya salah satu fungsi dari incineration itu adalah untuk membunuh patogen. Patogen itu berbahaya untuk kesehatan manusia. Jadi memang harus dimusnahkan dengan thermal yang tinggi, suhu yang tinggi. Karena resiko untuk kesehatannya lebih tinggi daripada manfaat apapun yang bisa kita ambil dari sampah jenis itu.
Oke, jadi tadi ya yang kotoran atau seperti dari bayi itu ya pampers atau dari lansia. Tapi yang sampah cair ini tidak didefinisikan mungkin, tapi minyak gitu ya buangnya beda lagi gitu ya. Minyak atau oli itu kan.
Bu,
ya.
Boleh mute?
Enggak mute saya.
Oh, enggak barusan Pak.
Sudah keluar ya. Oke, maaf. Yang sampah cair ini ya, bagaimana? Apakah bisa terjawab? Ya, misalnya oli atau minyak dapur, misalnya kan cair itu bagaimana? Ya?
Abura toka, daidokoro kara no karagen ato toka. Sore wado ya.
Almost is go to the incineration plant. But
okay.
Yeah, some local government made a biodiesel fuel. Yeah, and for example, from the convenience store, from the or restaurant, you usually go to the feeding, made feed for the 家畜だ。家畜の飼料。
家畜、farm とか
farm。餌。
Bobutsu esa, hai. Jadi yang ada juga yang bisa misalnya dari sampah-sampah dari misalnya restoran bisa ke peternakan begitu ya, yang masih bisa diolah untuk peternakan. Ya, terima kasih. Mungkin kita belum tidak bisa menjawab semuanya, nanti ya coba saya lihat ini dari Bapak Igede Oinada Sensei. Mohon tanya, apakah di Jepang ada pekerjaan seperti pemulung atau tukang loak? Terima kasih, menarik sekali pertanyaan.
Mr. Igede Oinada dari Bapak Igede, ini ada pertanyaan. The question is there such things as scavengers or people who sell scavenge materials like in Indonesia? Scavengers.
なんつうのかな。It's not same. So I said I developed the system for the collectors. This is a company. Yeah. Who collect and transport. We know the collecting and transport company. It's one of the business boundary we saw. So the situation is different in Indonesia and Japan. So I think that we don't say scavenger in Japan. Yeah, there is no. Yeah, I think so.
Okay, so because it's a company, so it's not a private. I mean, not a personal job or. So, Oke, baik. Jadi mungkin kalau tukang loak atau tukang jadi perorangan begitu ya mungkin tidak ada, tapi yang ada sudah jadi seperti perusahaan begitu. Mungkin di Jakarta saya sudah lihat ada beberapa yang memang berkeliling untuk mengumpulkan, tapi tidak satu-satu dari tempat sampah, mungkin mengumpulkan langsung dari pemilik rumah atau restoran dan sudah harus dikelompokkan mengumpulkan sampahnya apa ya. Jadi di Jepang jawabannya tidak ada pemulung sampah perorangan begitu mungkin ya, Bu Ana. Oke, berikutnya ini dari Ibu Ida Ismail, hanya komentar saja, plastic cannot be used for composting. Only organic waste can be composed. Thank you for the comment. And then from Ibu Karina Yasmin, there is kalau minyak jelantah, apakah ini sebuah permasalahan yang signifikan di Jepang seperti di Indonesia dan bagaimana Jepang menangani minyak jelantah? Tadi sudah ya, jadi sudah dijawab tadi ya. Jadi bio apa tadi ya, saya kurang paham ini bioenergi ya mungkin ya. Tadi minyak-minyak bisa atau bisa dibawa untuk makanan ternak ya di tempat tertentu diolah lagi. Kemudian ada lagi ini sama yang tadi juga untuk limbah dari grease trap, bagaimana pengolahannya?
So for the question is for the waste from grease trap, how
grease
to
trap.
treat it? Grease trap.
Incineration plant.
From the incineration plant maybe.
Yeah. So we have to spend a lot of cost to the incinerate grease trap stuff is one of the problem. Yeah, but the way of treatment is only incineration plant. Ya.
Oke, baik ya. Terima kasih untuk pertanyaan yang telah diajukan oleh para peserta. Thank you very much for all questions. I see the time is now 2:50. Maybe we would like to bagaimana Ibu Susi akan close?
Ya.
Oke, kami sudahi sesi tanya jawabnya. So today we already learned a lot about how trash sampah is problem not only for us but also from Japan. Maybe I cannot say that we have to learn, but maybe we could see how Japan educate, because there was also the educate problem that it is a long way to educate, but it is, I think, not a waste to try to educate maybe from schools, from houses, to start maybe from PET bottles, maybe from burnable and unburnable waste before maybe we have the robotic artificial intelligence utensils to help us about the trash and garbage and waste. So I would like to close this session and give back the time to Ibu Susi. Thank you very much.
Thank you, Lea Sensei. Thank you also for ONODA Hiroshi Sensei. And thank you also for Andante Sensei. Okay, before entering the closing session, as usual, our Zoom ritual, let us take pictures together. All participants, please open your videos. And Miss Astrid, would you mind to lead our photo session? Miss Astrid?
Masih di mute.
Yes, I would like to wait briefly for all participants to open their camera. Please open your camera so we can see your beautiful faces. We will wait briefly. Thank you. Okay, I think that is all. And now we are going to take the pictures. Please get ready for the pose. Okay, I will take from the first slide of the Zoom. 1, 2, 3. Okay, the next slide. 1, 2, 3. The third slide. 4th slide, and the 5th slide, and the last slide. Okay, thank you for the documentation.
Thank you, Ms. Astrid. To honor our speaker today with such an interesting and very inspiring presentation, we would like to present a moment of appreciation for Professor Onoda.
Ya, Mas.
Ibu Dia, the time is yours.
Yes, thank you, Ibu Susi.
Slideshow-nya boleh di slide.
どうも、本当にいろいろありがとうございました。とても勉強になりました。で、はい、お疲れ様。
ありがとうございます。
で、これからですね、The Certificate of Appreciation I will give to Professor Onoda Hiroshi. The Ambassadorial Lectures XI, 2023 Certificate of Appreciation is awarded to Professor Onoda Hiroshi for being the speakers of the lecture of Smart Approaches to Waste Management in Japan. This lecture is presented by the Center for Japanese Studies, Universitas Indonesia, in cooperation with Embassy of Japan in Indonesia on February 20th, 2023. Center for Japanese Studies, Universitas Indonesia, Diah Madubranti. いろいろどうもありがとうございました。お疲れ様でした。
ありがとうございました。Thank you very much.
Okay, last but not least, we arrive at the closing session. Dr. Lea Santia, would you mind to give our closing speech for this fruitful lecture?
Okay, thank you very much for the time. Thank you, Onoda Sensei, for today. And thank you for all participants today for your time to be with us. Today we already learned a lot about how Japan manages the waste in Japan, but still Indonesia maybe is still far away from all the technology the Japanese people have, but still we can put it as a target for us as Indonesian people to try to put aside our busyness every day and give more time to think about gomi, about trash and waste. Hopefully one day we could also be proud of ourselves to be able to manage our own waste. Maybe not up to zero, but lessen the trash and waste. Okay, maybe that is from today from Center for Japanese Studies. We also hope that we can meet again. We have the last lecture in March, if I'm not mistaken. Maybe Astrid Sang, could you put up the schedule on our next lecture? It will be, yes, this one is from His Excellency Mr. Kanasugi Kenji, the Ambassador of Japan to Republic Indonesia. It is on March 15, so we would like to invite all participants to attend this last ambassadorial lecture for this year 2023. Okay, so maybe we come to the end of our meeting today. Thank you very much and have a pleasant day. Goodbye.
はい、どうもありがとうございました。
どうもありがとうございました。
ありがとうございました。
Salam hangat, beribu terima kasih partisipan.
Ya, terima kasih untuk semua
Pada semua
partisipan.
partisipan, terima kasih.
Ibu Anna, thank you very much. Very helpful to have Andante Sam to really help me because I don't understand the question at all about waste and about a lot of things. Thank you very much to be with us. Ibu yang mau kenalan sensei nangka Ibu Susi sensei Kak Susi Sangkara nangka dare ka sensei no koto kiteiru hito ga imasu.
Ibu Hayati masih hadir di sini?
Where is she from? Ibu Hayati is from?
Ibu Hayati is the head of program studies of environmental management from School of Environmental Science in Universitas Indonesia. He would like to greet you and meet you another sense.
But I'm not sure if she is still in this Zoom or not. Is it okay if she asks for your email? Maybe I can.
Okay.
Yes. Okay.
Please share from Kawakubo-san.
Okay, I will share your
Okay.
email to
Okay.
Ibu
Yes,
Hayati
I will
later.
share you.
Okay, thank you, Onoda
Thank you very
Sensei.
much. Yes.
I don't use SNS.
Oh yeah, it's okay.
We also rarely use SMS. We use WhatsApp.
Yeah,
In
WhatsApp is
Yeah, yeah,
SMS.
yeah, I know.
WhatsApp
Yeah.
is SMS. Yeah. Okay, so if we can meet offline, you could meet a lot of people maybe from Indonesia, but now we are online, so maybe this is very difficult for us to greet each other.
Yeah, yeah.
So today we have